All right, so last thing we're going to do is find the area of any triangle. Oh, okay, fun fact. I mean, I just look up fun facts on the internet, but so Easter Island, which I really want to go there. Like, it's in the Pacific Island, I guess. I don't even know where Easter Island is. Like, but anyway, so those heads, like I've seen these heads before. They're everywhere. I guess that they go into the ground. Like, they have full torsos. Like, how crazy is that? They measure as high as 33 feet. That is insane to me. Like, and I mean, I just look up on the internet what these facts are. So if I ever tell you something and you're like, that's wrong, like, feel free to call me out. But we're just educating each other, right? So cool. Anyways. And, like, the ancient people somehow did this. Like, how the heck? I don't know. But let's get into triangles. So, area equals 1/2 base times height. Or base times height over 2 of a triangle, given the base and the height. Okay, we know that. But what if we're not given a base? And what if we're not given a height? We can still find the area. And we can use sine. Okay, so we say that we just have a triangle ABC. Well, we can drop a height. And then let's find, well, sine of C, sine is opposite over hypotenuse, so that would be H over A, which I could solve that for H. So A sine of C equals H. And then in this equation over here, I could plug H in right there. So this would be 1/2 B times A sine of C, which if you rearrange that a little bit, it's 1/2 AB sine of C. And you could find that or use that to find the area of any triangle. Okay. This works on any side angle side triangle. So it has to be side angle side because you have to have those two sides and the angle between them, but any side angle side triangle. So if we want to find the area of this triangle, well, this is a side angle side triangle, so it's easy for us. This would just be 1/2 15 times 12 times sine of 110, which is approximately 84.6 centimeters squared. Easy peasy. Okay, this one. So this isn't side angle side, but I'm given two angles and I'm given two sides. So I could find that other angle easy. Just do 180 minus 24 minus 31 and I get 125. So then this is going to be 1/2 17 times 14 times the sine of 125, which is approximately 97.5 meters squared. Cool? This one. So this is not a side angle side triangle, but we could solve this to be a side angle side triangle. So first, I would want to solve for that angle right there, which this is a side angle triangle. And if you remember back to the law of sines, if that opposite side is big, that means that there's just one possible triangle. So then this is going to be sine of theta over 7 equals sine of 93 over 12. So sine of theta equals 7, sine of 93 over 12. So theta equals sine inverse of 7, sine of 93 over 12, which is approximately 35.6. Okay, I still don't have a side angle side, but I can get it pretty easy from here. I just do 180 minus 25.6. Whoops. Is that math right? Let's see. 180 minus 35.6. I put 25, so now I'm like, did I do this right? 180 minus 35.6 minus 93 is 51.4. Yeah, that's right. I just put 25 instead of 35. But so that means that other angle there is 51.4. So then I can do area is 1/2 7 times 12 times the sine of 51.4, which is approximately 32.8 feet squared. Okay. This one, so we have a side triangle. Well, I could use law of cosines to solve for one of those angles. So I'm just going to do 22 squared equals 17 squared plus 16.5 squared minus 2 times 17 times 16.5 times the cosine of theta. So 22 squared is 484 equals 289 plus 272.25 minus 561 cosine of theta, which we can combine those to be 561.25. Then subtract that over, so I get negative 77.25 equals negative 561 cosine of theta. Divide by that 561. So cosine inverse of 77.25 over 561 equals theta. So theta equals approximately 82.1. And unfortunately, this is not drawn to scale, because that angle is obviously, it looks like it's obtuse, but it's really just 82.1. Okay, so our area would be 1/2 17 times 16.5 times 82.1, which is approximately 138.9 meters squared. And there's another way to find the area of side-side-side triangles. It's called Heron's formula. So first you have to find the semi-perimeter, which means that we add up all the side lengths and divide it by 2. Because if you add up all the side lengths, you get the perimeter. Divide it by 2, you get the semi-perimeter. And then you just plug it into this formula, and I'm not sure why it works, but I know it does. The square root of s times s minus a times s minus b times s minus c. Okay, so then for this triangle, if we do 17 plus 16.5 plus 22 and divide that by 2, we get 27.75. Plug it into the area part, so we'd have 22.75 times 22.75 minus 17 times 22.75 minus 16.5 times 22.75 minus 22, and take the square root of that whole thing. You get approximately 138.9, which is the same thing, which shows that this works for both parts. Okay? Let's just do one more. So if we find the semi-perimeter of this, we have 4 plus 6 plus 9 over 2, which is 9.5. And then the area would be the square root of 9.5 times 9.5 minus 4 times 9.5 minus 6 times 9.5 minus 9, which is approximately 9.6 meters squared. All right, bye. That's all.